Welcome to Summarize Science, where we break down complex research for you. Today, we're looking at a paper that explores the hidden relationship between an object's shape and how it behaves physically. Specifically, it's about something called torsional rigidity, a fancy term for how much an object resists being twisted. The authors use a powerful mathematical tool called the k-Hessian operator to study this. This isn't a new idea. Back in the 1960s, a mathematician named Pauli created a famous rule, or inequality, for this. Pauli's rule connected an object's twist resistance to its perimeter and area. He found that for simple 2D shapes, the stiffest possible shape for its size was a very, very thin rectangle. What this new paper does is generalize that rule for more complex situations in any dimension. In their main result, Theorem 1.1, the authors establish a new fundamental limit. This is like a law of physics for shapes, saying that the ratio of stiffness to size can never drop below a certain value. So, what's the new best shape that gets closest to this limit? The authors investigated this in Theorems 1.2 and 1.3. They added extra terms to the equation that depend on the object's thinness. This proves something crucial. A single perfect shape doesn't exist. Instead, the best possible candidates are sequences of shapes that get infinitely thin, like a cylinder being squashed flat. But here's where it gets really weird and differs from the classic case. In an example with ellipses, they showed that as you make the ellipse longer and thinner, its generalized stiffness can actually go to infinity. This means that unlike the simple case, there isn't always an upper limit to how stiff these shapes can be, which is a very surprising result. The paper doesn't stop there. It also looks at a related property. This property is the eigenvalue, which you can think of as being related to an object's natural frequency of vibration. In Theorem 1.4, they found an opposite kind of rule for this property, an upper limit. It states that no matter the shape, its vibration-related properties can never go above a certain value. So let's recap the key discoveries. First, the researchers created a new universal rule connecting a generalized measure of stiffness to an object's shape. Second, they showed that the most optimal shapes for this rule are ones that are infinitely thin. And third, they found that in some cases, this stiffness can be limitless, a major departure from older theories. This type of fundamental research is incredibly important. By understanding the deep link between geometry and physics, these mathematical principles could one day help engineers design stronger, more efficient structures and new materials. Thanks for watching Summarize Science.